Good morning, students. Welcome to Good Samaritan School online classes. In the last class, we discussed on magnetic field due to the current through a straight conductor, magnetic field due to the current through a circular loop, and also magnetic field due to the current in a solenoid. So in each case, we have learned with an activity, and also we have learned how the patterns of magnetic field, different patterns of magnetic field which is formed on different types of the conductors. For example, with straight line conductors or with circular loop, and also with the solenoids. And today we are going to discuss on the force on a current carrying conductor in a magnetic field with an activity. Okay, let's start with an activity. So in the last class, we have learned that electric current flowing through a conductor produces a magnetic field. So whenever an electric current is flowing through a wire, it produces a magnetic field around them. Okay, the field so produced exert the force on a magnet placed in a vicinity of the conductor. Okay, this was first introduced by a scientist called Andre Maria Ampere in 1775 to 1836. He was a scientist who first introduced this process. Okay, let's do with an activity so that you will understand what this topic talks about. You can take your book and turn to page 230, and there figure 13.12. Activity 13.3 talks about this small activity, and this activity here have drawn a diagram here. It is stand, and we have an strong horseshoe magnet, and this horseshoe magnet is suspended in such a way the south pole is on the top and north pole is at the bottom. Okay, so if the horseshoe is like this, then the AB is a aluminium rod which will be suspended in between them. Okay, it looks like that. Can you understand? Imagine this is a horseshoe magnet, and this is the AB rod which is inside this. Clear? And this, for example, this is a point A and this is the point B, so it is pointing towards like this. Okay, can you imagine this now? Horseshoe magnet. So this is my south pole and this is my north pole, so you can imagine that, and the rod AB is kept in between them. So what happens, and these things is connected with a battery. So the positive is connected with the B and the negative is connected towards A. Okay, let's see what happens in this observation of this experiment. If you watch carefully, the force is expressed by the current carrying conductor, that is AB. So when we apply electricity, and this rod is actually kept in between the magnetic field. Okay, and before that what we did, we have a magnet, a normal magnet, and then magnet have a magnetic field around them, and if you keep any magnetic material like a compass, so it shows a deflection, right? But here what we are learning is we are keeping a current carrying conductor inside the magnetic field. Okay, and see what is going to happen. A force is expressed by the current carrying conductor AB when placed in a uniform magnetic field. So what is happening here? There is a force is expressed, so there is a movement comes. So what happens when it is south and the north pole direction, and the aluminum rod is kept here? So when the current is flowing from B to A, okay, it moves like this, पॉजिटिव यहाँ से जाके and B to A जा रहे हैं ना, so it expresses the movement like this side. Okay, it looks like this and it moves towards that side. Okay, that is what happens here. So the direction of a force on the rod can also be changed by reversing the direction of the magnetic field. What you can do, you can now invert the or you can just rotate the magnet, so the north pole comes on the top and south pole goes to the bottom. Now you see what happens, then the movement will be reversed like this. Or what we can do, we can change this battery. For example, here you can make it negative, and here you can make it positive, then also the movement will be reversed. Okay, so this is what happening. The direction of the force on the rod can also be changed by reversing the direction of the magnetic field. What it means? By placing the north pole above the rod and south pole below the rod. So what we are concluding from that? We're concluding that the direction of the displacement of the conductor, that means the movement of displacement of the conductor, for example AB, sometimes you see that south is on the top, north is on the bottom, the movement will be like this, and north is on the top, south is on the bottom, movement will be like this. Okay, that is what we are taking. The direction of the displacement of the conductor depends on, first thing, direction of the current flowing through the conductor. If the current is flowing from B to A, then the movement will be towards the left hand side. Then if the current moving from A to B, reversed current, then the movement will be towards right hand side. Okay, anti-clockwise and clockwise and anti-clockwise. So the second thing is the direction of the displacement of the conductor depend on the direction of the magnetic field. So either you can change the direction of the magnetic field by keeping south pole and north pole, or north pole on the top, south pole on the bottom. Then also the direction of the displacement of the conductor will change. Okay, that is what we are learning from this activity. So based on the same similar activity, we are going to learn Fleming's left hand rule. Okay, in Fleming's left hand rule, we are going to take the same activity. In that activity, what we learned, the displacement of the rod is maximum when it is at right angles to the direction of the magnetic field. So if I just want to show it once again, you see this is the magnet, and the magnetic field will be here, and the rod is at exactly at the right angle. Okay, this is the magnet, and the bar magnet is exactly at the right angles. Okay, right angles. That's what here is saying, that the displacement of the rod is maximum when it is at right angles to the direction of the magnetic field. Okay, based on this, what we are going to learn? We are going to learn that, okay, when it is at right angles to the direction of magnetic field, in other word, we can say that magnetic field of a U-shaped magnet is perpendicular to the current carrying conductor, that means rod. For example, this is the U-shaped magnet, and the rod is exactly perpendicular to the horseshoe magnets. Okay, this is what we are learning. So we can say that force, in other word, a motion on the current carrying conductor, when it happens, first thing, is always perpendicular to the plane containing the current conductor of the direction of the field in which it is placed. First thing, always the force or a motion takes place. When it will take place? When the current carrying conductor, okay, is fixed exactly perpendicular to the direction of the magnetic field. Second thing, the force or a motion on the current carrying conductor is maximum. When it will become maximum? When the conduction is right angles to the magnetic field. Okay, if it is right angle to the magnetic field, exactly you can find it is moving towards in a proper in other word, the force will be maximum. Okay, that is what we are going to learn. Okay, Fleming's left hand rule is here. You can stretch your finger like this. For example, your middle finger, your forefinger, and your thumb. Okay, keep it like this, and this thumb and is perpendicular to the field, and this is perpendicular to the current. Okay, I try to give you an example like this. Okay, if I keep it like this bottom, so current will always taken from the ground, so you can take that middle finger is a current, and this forefinger is pointing something, it pointing a field. So you think that, okay, magnetic field. And this, it talks about some kind of a motion or a force. Okay, what is happening here? Let's take an example. When a current is moving in this direction and the magnetic field is in this direction, the motion will be always ऐसे जाता है. Can you understand that? It moves like that. So it's always these three things should be in a perpendicular order, and you have to keep it in your mind. The left hand rule says that the current, this is the middle finger, current, and the field it shows is a magnetic field and the force. Even you can keep an example like that. This is your, you can keep it as m, motion, mother, and this is for motion, this is a magnetic field, so it's father, and this is a child, in other words c is a current. Okay, it's easy for us to keep it in your mind. Child, father, mother. Okay, so mother is nothing but motion, m for motion, and father is nothing but f for field, magnetic field, and c is nothing but a current. Okay. Okay, what are the factors affecting the force or a motion? What are the factors affects? First thing is the strength of the electric current flowing the conductor. If the force is more, when it will be more? When the current is more. In other words, the motion is more. When the motion is more? When there is a more number of current. Okay, that is what F is directly proportional to I. Second thing is the length of the conductor. If the length of the conductor, even it is an aluminum rod or whatever it is, here we have taken AB aluminum rod, right? If the length of the conductor is more, then the force applied it shows is more. If the length of the conductor is less, the force which is takes place is also less. The third thing is the strength of the magnetic field. If the force is more when we have large number of magnetic field. Okay, B talks about magnetic field. And the force will be less when we have less number of magnetic field. Okay, these are the factors that are affecting the force or a motion. The next topic we are going to learn as an electric motor. What are electric motors? Okay, before that we are learning about the magnetic field is producing an electricity, right? I just want to give you a short note. An electric motor is a rotating device, right? And that converts electrical energy to a mechanical energy. So electric motor is used as an important in electric fans, refrigerators, mixie, washing machines, computer, MP3 players. Everywhere we are using only electric motors. Okay, let's see how this motor works. Okay, so I have made a design here. This is a north pole magnet and this is a strong south pole magnet, and there is a coil of a rectangular coil, okay, copper coil, which is placed in between them. Okay, these are the coil which is rectangularly made. Okay, and this is connected with a battery, and this is connected first with a brush. Okay, this is a small one. X and Y are the brushes, and this brush is connected to a battery, positive and negative. Clear? And this brush is just touching the rings, and these are the rings, and the ring is attached to the axle. Okay, some kind of you can take an example. This is an axle. Okay, I have kept two rings which is attached just to an axle, just holding like this, and this ring is not touching the axle properly because this axle is a metallic axle as a rod, and रिंग एंड एक्साइल के बीच में एक इंसुलेटेड का कोटिंग होता है, सो दे नेवर कंडक्ट एनी इलेक्ट्रिसिटी टुवर्ड्स दिस एक्साइल. Okay, will you understand that? So what happened? The current is flowing in this direction, and through AB and CD, the current will come reverse, and then it moves towards here. Okay, you have to this electric motor is works on the basis of Fleming's left hand rule. That is what very important, because everything will be perpendicular to each other. Okay, the current is coming this side. Okay, and this is the magnet, and it shows a magnetic field in this direction. Okay, for example, this is the north pole and south pole, magnetic field in this direction, and this is the current I, this is field. Okay, and the movement will be always opposite. For example, इसका नीचे एक line लगाएंगे तो कैसे होता है? That is how the motion takes place. Will you understand now? It looks like this. Okay, so motion, the M will be go down, and the field is somewhat like that side, and current is coming this side. Will you understand now? This is how this electric motor works. And how it works, let's learn it. When the current is passing through A, B, C, D, okay, this is kept in the perpendicular to the magnetic field. So magnetic field will be going like this. Okay, from north pole to south pole, it moves like this. So when the current moves towards X and then to the axle AB, so what happened? It moves towards this side. So this rim, this split rings, what happened? They started to move. As I told you, they show some motion, right? This is a magnetic field. I can show like this. This is current which is passing through A and B, and the magnetic field is like that. The motion will go like that. नीचे जाता है. So it rotates in an anti-clockwise direction. So what happens? AB will go down and CD will come up. It will be like that. This is A, B, C, D. So first rotation, it goes like this. Okay, C, D ऊपर आ जाता है, A, B नीचे जाता है. And then immediately what happened? This bush will never, this brushes or will never move. Only the rings will move. And what are the rings here? P and Q are the rings. So what happened? When it rotates a full rotation here, the Q will come and touch the X, and P will go and touch the Y. एक rotation जाता है. Can you understand now? And then when it go and touches, Q will touch a X and P will touch a Q. Sorry, when Q will touch X and P will touch Y, that means ऐसे जाता है. Immediately the current will get reverse. When current will get reverse, then what happens? Again the normal position. Again it now A, B, C, D will be there, go down. When the current get reversed, then it again come back to the original position. Okay, where it comes, AB will come back to the same position and CD will go to the same position. So this is how the current works in an electric motors. Can you understand it? Here what happens? Off rotation, Q makes contact with X brush and also P with the Y brush. Therefore, the current in the coil gets reversed and flow along the path DC. So DC BA. So reversely जाता है. A device that reverses the current or flow of a current through a circuit is called commutator. And who is act as a commutator? Actually, what is commutator? Commutator is nothing but a device that reverses the direction of the current. That is commutator. And now who is acting as a commutator here? Yes, the rings only act as a commutator because they only rotate. And when Q will touch X and P will touch Y, what happen? Immediately the current will also get reversed. Can you understand now? So the reversal of the current also reverse the direction of the flow of acting on two arms of ABCD. Thus, the arm AB of the coil that was early pushed up is now pushed down. Clear? So this is how the full mechanical work takes place on the electric motors. Can you understand that? So what happened? First it moves to a clockwise direction. Therefore the coil of the axle rotates another half in turn same clockwise direction. So this is how this it works in a electric motors. And there are lots of uses of these electric motors nowadays, and that we have learned in the starting of this topic. It works in a refrigerator, mixer, washing machines, computers, MP3 players, etc. Okay, this is how for today, and we have learned on electric motors today, and also we learned on Fleming's left hand rule, and also we have learned on the force of current carrying conductor in a magnetic field. So always you have to keep it in your mind, when the direction of the current, that means the direction of the displacement of the conductor, it depends only on the direction of the current flowing through the conductors, right, and the direction of the magnetic field. Okay, these are the very important things you have to know, and it's very important question is the Fleming's left hand rule, and also electric motors are very important questions in this topic. So we'll see about electromagnetic inductions, and also Fleming's right hand rule in our next class. Thank you, student, and have a nice day.